All right. Hi, this is the second part of our 4.5 graphs of tangent, cotangent, secant, cosecant. We learned a lot last time, and I'm going to just point out a couple things that we didn't hit the first time. The first is, and it was mentioned, but I want to say it again, here's the graph of tangent, right? It's lovely, it's beautiful. Notice that the distance between the asymptotes is a distance of pi. What is that also? It's the period of tangent. It's the amount of time it takes before the function completely repeats itself. So this is really, really important. And I want you to kind of note that in your notebook at some point, that the period of the parent function of tangent is pi. Okay, very important. We didn't talk about the period of cotangent, but if we notice again, the distance between the asymptotes is also pi. So we can say that the period of our parent function of cotangent is also pi. Then let's consider secant. Notice if I consider, like, let's start right here. I need to see how far this function goes until it completely repeats itself, exactly the same. So notice that we've got this parabola opening up, and then we've got one that opens down. Those are different. And then we go back to this one that opens up. So I repeat myself after I have both the open and the, not open, the opening up and opening down, which means if I look at these asymptotes, I'm going from negative pi over 2 to 3 pi over 2. That means the period of secant is 2 pi. This shouldn't be super surprising because secant is so closely related to cosine, and we know the cosine period is also 2 pi. And so hopefully that doesn't shock you then to say, if we look at cosecant, the period, the time it takes to repeat itself, is also period 2 pi. All right, let's look at a couple very, very fun examples. We're going to start with y is equal to secant of 2 theta. So the first thing I want to ask myself is, what function are we dealing with here? And you can kind of consider this, or one way to do this problem would be to graph for cosine of 2 theta, right? Because secant is the reciprocal of cosine. Then erase your cosine graph and just draw your little parabolas and asymptotes when needed. So I think let's do that. Considering cosine, what do we notice? Well, we notice that b is 2. The original period of cosine is 2 pi. We divide our original period by b, so 2 pi over 2. The period of this new graph is pi. And I see the 4 out front, which tells me this function has an amplitude of 4. No horizontal shifts, no vertical shifts, so we're good to go. I know that my period is pi, so I am going to start by drawing pi here. Because I'm not going to the left and to the right, this is the entire distance of my period, from 0 to pi. I'm going to cut this up into my 4 equal pieces, which means I'm going to start by cutting it in half, pi over 2, and then cut each of those in half, pi over 4, and 3 pi over 4. Now I'm going to take a moment and extend this x-axis, to the left and to the right. So negative pi over 4, negative, pi over 2, negative 3 pi over 4, negative pi, and we can just keep kind of drawing some points, but I'm not going to label them all. So this would be 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which is really 2 pi. My y-axis, I want to be 1, 2, 3, 4, 1, 2, 3, and negative 4. And now I'm going to sketch in cosine. Cosine, we remember, starts high. So my first point is going to be at 0, 4. Then it goes to the midline, down below, back up to that midline, and up. Notice that this one rotation has a total period of pi. Then I'm going to keep this motion going just kind of to give us a little more structure here. And on the left side, and I'm going to sketch in my curve. It's not going to be perfect, so please bear with me. Oh gosh, see, that was not great. It's okay. All right. Now, this was not actually the graph we were asked to draw, right? We're asked to draw a secant. So I am going to take this and kind of make it really light. You, in a moment, might want to erase yours or just highlight the graph of secant. What do I know? I know secant will have asymptotes where cosine is 0. So in this case, it will have an asymptote at pi over 4, at 3 pi over 4, 5 pi over 4, 7 pi over 4, negative pi over 4, negative 3 pi over 4. And then we know it has the same maximum and minimum points as cosine, although they're not maxes. Well, it's a maximum here on cosine, it's a minimum on secant. And then I'm just going to draw it where it kind of goes towards those asymptotes. And my friends, we just drew the graph of 4 secant of 2 theta. Now you might be sitting there thinking, I don't believe her. So guess what? We're going to check using Desmos. All right, I know this looks really busy. Trust me, I'm just going to show you that it's the same graph. So we've got these, if we notice, the first function has a point at 0, 4. All right, we got this 0, 4 right here, and we're opening up. And if you notice my asymptotes at pi over 4 and negative pi over 4, I would feel pretty good. Those look like the asymptotes they should be. And then we've got our parabolas kind of opening down and then up. So I feel very confident that the graph we drew is the correct one. Yay, congrats. Let's try another. This one wasn't actually on your notes sheet, but it's okay. We're going to do it together right now. Y is equal to 5 tangent of 1/2 x plus pi over 8. Okay, this one is a little more complicated, but we got this. We're not worried. The first thing we want to do is make sure that we factor out b. So instead of this 1/2 times x plus pi over 8, I'm going to factor out a 1/2 here. I'm going to write it as 1/2 times the quantity, x plus, now I'm technically like dividing by 1/2 here. And so you're multiplying by the reciprocal, which would be 2. 2 times pi over 8 would be pi over 4. And if we think for a second, just to check our work, like if we were to distribute this, right, we would get pi over 8, and so we're super happy. And we still have this, where's my blue, tangent, and 5 out front is equal to y. Okay, now we can begin. What do we notice? Well, I notice that this is going to be our amplitude, although it's technically not an amplitude with tangent because tangent doesn't have these maxes and mins. But we are going to make a note that a is equal to 5 because we need that. We've got a vertical stretch. We've got the 1/2. Okay, so we got to think of our period of tangent of the normal parent function is just pi. Then we divide it by b, divided by 1/2. That's equal to 2 pi. So this is our new period. And then we've got this plus pi over 4, which is a horizontal shift. It is going to move us to the left pi over 4. All right, let's draw our graph. The first place we want to start, or that I think makes the most sense to start with tangent, if we just consider normal tangent, kind of looks like this, right? With our asymptotes at pi over 2 and negative pi over 2, and this point right in the middle. I think it makes the most sense to start with that point and then find the asymptotes from there. So if normally it's the point 0, 0, and I know I'm moving to the left pi over 4, that means I know that at the very least, I need a point at negative pi over 4. Now, because I'm starting with pi over 4, I'm just going to automatically scale my axes to pi over 4. So let's do that right now. I'm going to work on the positive first. 1/4, 2/4, pi over 2, 3/4, 3 pi over 4, 4/4, pi. I'm going to keep going 5 pi over 4, 6 pi over 4, 3 pi over 2. Oops, little typo there. 3 pi over 2. Where were we? 5, 6, 7. 7 pi over 4. And then 8 pi over 4. which is 2 pi. And I'm going to go to the left as well, negative pi over 2, negative 3 pi over 4, negative pi, and I think that's as far as I'm going to go on the left. I know this original point at 0, 0 is shifted to the left, so this is one point I know is on my graph. Now, let's consider the period. So again, a normal, well, I keep saying normal. The parent function of tangent has a period of pi. And it's perfectly not perfectly symmetric, but it's equidistant. This point in the middle is equidistant from each of these asymptotes. So that's why we have the asymptotes at pi over 2 and negative pi over 2. If my new period is 2 pi, that means I need to go pi to the left of this point and pi to the right of this point. I know that my graph is currently cut in fourths, so if I want to go pi to the right, I'm going to count 1, 2, 3, 4. Right here is a distance of pi. And then to the left, 1, 2, 3, oops, I need negative 5 pi over 4. To the left, this is a distance of pi. And now the total distance between these asymptotes is 2 pi. Now notice I could keep going. I need to add 2 pi to 3 pi over 4. So one way I could do this is by actually adding. I need a common denominator, so it would really be 8 over 4. 8 plus 3, 8, 9, 10, 11 pi over 4. And I could keep going here. So this is 8 pi over 4, 9, 10, 11. I know my asymptote's going to be over here, and I don't have enough space to the left. But we are going to keep moving to the left and to the right with a period of 2 pi. Now let's think about our beautiful graph of tangent. In the parent function, it has a point at pi over 4, 1. Notice that pi over 4 is right in between this middle point and the asymptote. Okay, so here's my middle point. Here's my asymptote. I know that exactly in the middle of those two is going to be my next piece. There are 1, 2, 3 options. That means I know it's got to be right here. And here's where our A comes in. This is a vertical stretch. So instead of just pi over 4, 1, we are going to go 1, 2, 3, 4, 5. Sorry, this is not, did not space this very well. Pi over 4, 5. And then we're going to go to the left, halfway between, and at negative 5. Let me give myself a little more space and then draw in this really, really tall graph. Oh gosh, hold on. All right, thank you. I just had to make that smaller and keep going. If we want to do another period, which we probably should, we need to find exactly the midpoint of these two asymptotes, which is also pi distance away from the asymptote. So 1, 2, 3, 4. Also, it would be 1, 2, 3, 4. So we're good. And then halfway between there, down at negative 5, halfway between, up at positive 5. And I've got, oops, another period of that. Not flawless, but, you know, you're going to forgive me, I think. And again, let's check using Desmos. So notice we've got this point at negative pi over 4, and then we've got this point at pi over 4, 5, and the asymptotes at 3 pi over 4 and negative 5 pi over 4. I'm going to start by typing in our function, and here's my graph. It looks pretty good, but let's check. Notice we've got this point, negative pi over 4, 0, yay. I've got the point pi over 4, 5, right here. And then if I throw in those asymptotes, 3 pi over 4, negative 5 pi over 4, I don't know about you, but those look pretty accurate. So good job. Congratulations. You made it through your second graphing transformations with the tangent, secant, cosecant, and cotangent. I got one more quick example for you in this section. It's not on graphing, it's just solving. So it says, where is secant equal to negative square root of 2 for pi to 3 pi over 2? So let's think about this. Notice secant, remember, is the reciprocal of cosine. So that means if secant is equal to negative square root of 2, cosine of that angle will be equal to the reciprocal, or 1 over negative square root of 2. But we're smarter than that. We don't like that. We rationalize. So cosine is equal to negative square root of 2 over 2. All right. Oh, gosh. Sorry about that. We are looking for then the places where cosine is equal to negative square root of 2 over 2. Okay, take out your unit circle. Oh gosh, that's a terrible unit circle. It's okay. I know cosine. Sine is y, cosine's x. Okay, cosine is negative over here. And cosine is equal to the square root of 2 over 2 at our pi over 4s. So here is 3 pi over 4, and here is 5 pi over 4. Technically, these are our two answers, but they specify they only want it where x is between pi and 3 pi over 2. Where does that leave us? Pi is right here. 3 pi over 2 is right here. They are asking for the solution in quadrant 3, which means my only answer here would be 5 pi over 4. All right. If you have questions, please let me know, and I will talk to you soon.